All right. So, hello everyone. How are you all? All right. So, welcome to this lecture. And today we will be discussing the previous year problems of CBSE Board 2024-2025, and we will be discussing the previous year problems on the topic of applications of integrals. So, all right. So, hello. So, I hope I'm audible to all of you. Okay. So, let's start for our discussion on the previous year problems of the chapter of applications of integral. So we are going to focus the CBSE examinations and we will be discussing with them previous year problems. Okay. So my name is Sirsha Banerjee and I'm I'm a student from IIT Kharagpur and we will be discussing the previous year problems. Okay. So our agenda for today is to discuss some of the important topics from the chapter of applications of integrals. So before we start with the integrals, I will be discussing about like what are the important topics that you need to prepare in integrals in order to solve some questions of applications of integrals. After that, we will be discussing about what are the different methods for solving questions in applications of derivative, as well as including that into your integrals and how you are combining that to solve questions of applications of integral. After that, we go on to understand that there are graphical representations in order to solve applications of integral problems, and we will discuss that in our today's class. And at the end, we will be discussing what are the different paper strategies that you can follow in order to help to ace your marks in your CBSE examinations. All right, so here we have some of the important properties before we start on definite integral. So these properties are very crucial and important to start up. So first of all, you can see that we have some crucial important definite integral properties, that the definite integral of a function f of x from a to b doesn't depend whether we change the independent variable that we can also have in terms of t. Okay, so it does not depend upon x. Okay, so that's the important property, which is the first property. Secondly, if we are having integral from a to b of fx dx is equals to minus of b to a f of x dx. After that, we have another important property, that is called the property where we can split the integral inside the domain. For example, if we have the c which lies inside the domain of a to b, then this property is called the piecewise, and f is a piecewise continuous function, then we definitely split this definite integral into two parts, one from a to c and from c to b. So therefore, it is basically useful when we have the function f of x is piecewise continuous in this particular interval a to b. For example, like f is piecewise continuous, so it is continuous from a to c and another continuity from c to b. So that's when we use this particular property. Is it fine? So next property we're going to be talking about is a very crucial and a very important property, is the symmetric property. That is, for a given function f of x dx from minus a to a is equals to 0 to a is equals to f of x plus minus of f of x. Okay, now the importance lies over here is that when this f of x is an odd function, so for odd function f of x is equals to minus of f of x. So when it is an odd function, so this particular summation is going to be equal to 0. So that is 0 for f of x given this an odd function. Okay. Now the case if f of x is an even function, we will have the case as, so f of minus of x is equals to f of x for even function. So this was for odd and this was for even. So when it is even function, this summation will sum up and it's basically 2 times of integral 0 to a fx dx. I hope it is clear. Next property is a very crucial property, and this is the property from where you can expect to get most of your questions coming up. Okay, so this property talks about is that, so for a given integral from a to b fx dx is equals to integral a to b f of a plus b minus x dx. So in particular, if we are having 0 to a, then this can be shortenedly also written as f of a minus x for the integrand part. Alright, so this is very crucial and a very important property. I hope you must remember this part. Next property we talk about is that for is basically the splitting the limits. Okay, it's like for the integral within limit 0 to 2a f of f dx, so we can split that from 0 to a f of x dx plus 0 to a f of 2a minus x. Now the thing is very easy is to over here is that, so if f of 2a minus x is equal to f of x, then it is basically equal to 2 times of 0 to a f of x dx. So that's how we split it. So we split the upper limit into two integrals, and if this part is equal to minus of x, that is f of 2a minus x is equal to minus of x, then we are having the answer as 0. Alright, so that is simple. Next we look at the property which is called the periodic property of integral. So whenever we have a function f of x with a periodicity t, then that particular property can be given as f of x dx from 0 to nt is basically equal to n times the integral 0 to t f of x dx. Alright, and lastly, also one more property for periodic function is that when we have a periodic function for the given integral within the limit a plus nt b plus nt for this function f of x, which is basically a periodic function with a period t, so then I can write it easily as integral a to b f of x dx. It's just like a periodic function. So how can if I try to represent that, for example, I have a periodic function like this way. So this kind of function is repeating after certain interval. So let us call this period as t. So it is repeating after certain interval, right? So if we are taking any inside any interval, so that part can also be given as whether we take in a longer interval or whether we take in a shorter interval. It is basically the same thing. So nt part will be the same for the both the things, but we are taking the integral from a to b. So it doesn't matter like where we are starting at. Okay, so that's what is basically meant by this property. I hope these properties will be a basic and crucial for your understanding and learning part. So with this, let us start solving the previous year CBSE board exams questions. Okay, so I have taken up mixed problems from different years, and with these questions I'm going to tell you like how you are going to solve the problem in when it is basically going to be coming up for exams. So let us see the first problem. So we're going to solve the first problem over here. So first of all, let us try to read what the question has to say. The question says that the area of the region, so we have to find out the area. Okay, so before we start with the topic, you should be very clear in your mind that what is the thing that is basically asking the problem. You have to have a clear understanding of what is the part that is going to be asking the problem and how we are going to tackle it, right? So first of all, if we are looking at the problem, it is basically asking the area of the region. So a quick review. Okay, so a quick recap is that when we are having integral, when we are having definite integral from, let us say, from a to b, so the definite integral of, for example, we have any curve like this way and we are taking a definite integral from a to b, so definite integral implies it's basically the algebraic area. So this particular area is given by definite integral a to b f of x dx, as simple as that. But the problem is that when we calculate or evaluate this definite integral, I'm going to have values of sign, right? So that's why we say that definite integral returns a algebraic value, whereas Whereas when we calculate for area under the curve, I will definitely take the integral as mod of f of x. So that's the difference. Okay, so when we talk about area under the curve, we are definitely meaning geometric area. So that is the area, geometric area. Okay, so we are basically looking at the cumulative area rather not the area with a given sign. All right, so let us try to understand what this question has to say. So if we look at the problem, it is saying that we have to calculate the area under the curve. So we have to calculate the area under the region which is bounded by the lines. So now while we are solving the problems of area under the curve, it is very important to bound the region or to bound the region by the given curve. So for that we have to start drawing the curve equations. So first of all I will write the curve equation y is equal to f of x, and it is said that the region is bounded by this particular straight line as well as the lines x is equal to 1 and x is equal to 2 and the x-axis. So that is basically the region we are basically talking of in this problem. So if I try to, so whenever you are going to solve that in your board exams, okay, so you have to basically clearly mention that the given region is. So your statement should be starting like this. So you know that when you are going to appear for the board exams, it's very crucial to explain everything while you are writing up answers. Okay, that will give a very clear impression to the examiner who is checking your paper. So that is something that is very crucial about. So whenever you are practicing any problems in your home, you should have that habit of writing the solution as if you are explaining to someone else. Okay, now that will actually help you to grasp a good marks in your board exams. So given that, so I will first of all write the given region. So given region is bounded by the curve that is given as y is equal to mx, and I have x is equal to 1 and I have x is equal to 2 as well as the x-axis. So it is asking me that this particular region, the area of the region is basically given as 6 square units. So then you would talk about the value of m. So very simple problem, very straightforward. So let us first of all try to draw the region. So y is equal to mx is a straight line passing through the origin. I don't know about the slope right now, so I will draw any straight line like this. Then it says that it's bounded between the line x is equal to 1 and x is equal to 2. So I will draw two vertical lines, x is equal to 1 and x is equal to 2, like this. I hope this is clear. So now, and also x-axis. So the required region we are looking for is basically this particular region. So let me take a highlighter and highlight this. Okay, or maybe different color. So yeah, we are looking at this particular region. Okay, so the region basically bounded by these three equations of lines: x-axis, x is equal to 1, x equal to 2, and this straight line y equals mx. So from here I got the information about the region. So I have to find out the area of this particular region, and that we have to equate it to 6 square units. So how are we going to solve this? Very simple. So when we have a region bounded by this, so the bound of this integral is from x is equal to 1 to x is equal to 2, right? So the area for this particular thing, since it is coming up in the positive part of the y-axis, so I will definitely not put a mod, because even if you put a mod, you're going to get a positive result. So this part is going to be like f of x dx from 1 to 2, fine, and that part is given as 6. So now let me erase this part and let us show you the solutions over here. All right, so from here if we carry on the calculation, so integral 1 to 2, I have the function, and the function curve is basically this part. So this is y is equal to mx. So I will put mx over here in place of y times dx, and the area is given as 6 square units. So I will carry over this integral. It's a very simple integral. So the integral will be like m into x square upon 2 within the limit 1 to 2, and the value is equal to 6. So from here I will have the value of m as, that is basically 6 divided by this part. So if we put the value of the upper limit and the lower limit, I'm going to get the result as, so for the upper limit I will be having 4 by 2, that is 2, and for the lower limit I will have 1 by 2. So 2 minus 1 by 2 is going to be 3 by 2. So m is equal to 6 upon 3 by 2. So from here the result is going to be equal to 4. So that is your option number B. So I hope you can see how simple the problem it is, right? So this is going to be your correct answer, right? So I hope there is no more confusion in this problem. It's very straightforward and simple problem, right? So if you are able to understand this, please let me know. Okay, in your live chat you can also message. I hope this is clear, right? You can start like writing anything. If you have any queries, you can tell me. All right. So since there is no questions, so we can move forward, right? All right. Let us move to the next problem, and the next problem is kind of similar problem, but the function is different in this case. So earlier the previous case I was having the function as a straight line. Over here I have the given function as a hyperbola. Okay, so this is basically a rectangular hyperbola, right? So again we have to find out the area of the curve, right? So again if we read the question, we have to find out the area of the curve bounded by this rectangular hyperbola between these lines x equals to 1, I'm sorry, between this line x equals to 1 and x equals 3 and the x-axis. Okay, so let us start how to solve this problem. Again, very simple to the last problem. So the way you are going to write that for your CBSE board examination is that, so first of all mention the given region. Okay, so first of all clearly mention about the given region. So your given region is given as xy equal to 4. So from here we will be separating at y equals to x upon 4, right? So that's the function, and I have to find out within the interval x1 to x3 and also the x-axis, right? So that is basically going to be the bound of my region. So given this type of question, again the same solution is that you have to first of all try to plot the region. So you will plot the region over here. So this xy equal to 4 is a rectangular hyperbola. So I will be discussing about that. So generally the rectangular hyperbola, the graph of the rectangular hyperbola looks like this. Okay, so I'm drawing only the positive part of it. Okay, because I need to find out the area bounded by the x equal to 1, x equal to 3 and x-axis, that is in the positive half. So the rectangular hyperbola is basically like this. So you can write it over here. So this is the curve equation y equals to 4x. So starting for x equals to 1 to x equals to 3. All right. So from here, I hope it's clear, right? Okay. So from this part and the x-axis, right? So this give me my given region as, so this is my given region, right? This is again my given region. Now when it comes up in your board exams, you also have to follow the same step, same process, and the way I'm writing it down step by step, you are going to follow the same thing. All right. So after that, so from here if I need to find out what is the given area, so again I'll find the area given as within the interval a to b mod of f of x dx, right? But since we are talking about the positive region, so this mod of it will definitely give you a positive result. So this particular, the area will be from x equal to 1 to 3 for the interval 4 by x mod of it. So I don't need to put a mod again over here, explain the thing. Okay, so then we will have it into dx. Now it is, the simple solution is basically to carry out this integral. So we know that integral of 1 upon x dx is equal to natural log x, right? So this is basically going to be ln of mod of 4, ln of, so since 4 is a constant it will come out, so ln of 4, okay, mod of 4, and 4 is a constant, it will come out, right? And within the interval or limit 1 to 3. So if I just calculate it out, so let me solve it over here, I have a space over here. So over here, this part is going to be equal to 4 times of log of 3 minus log 1. Log 1 is 0, so the simple answer is basically 4 times of log 3. And you know, in logarithmic, there is a property that is a times of, for example, a times of log m. Now let us say we have base b, so this is particular part equal to log m to the power a, sorry, m to the power a, m to the power a with the base as b. Fine. Okay, so and this particular thing we can expand over here result as, so it is going to be natural logarithmic of 3 to the power 4, that is going to be 81. So your solution to this problem is basically ln 81 or natural logarithmic 81, that is option number C. That's going to be the solution or the answer. Is it clear? I hope the solution is visible to you, all of you, and it's clear, right? Any queries, any confusion, you can definitely put that in the chat. Okay, so with this, let's move to the next problem. So our next problem is another simple problem from the chapter of applications of integral. So the question says that it's again very simple, we have to solve this integral. So let us proceed for the solution of this. So again, when this come up for your exams, the way you have to solve it is basically, first of all, let us assume this integral is equal to some value, let us call this I. The integral is from this log root 2 to log root 3, and the given integral is given as 1 upon e to the power x plus e to the power minus x multiplied with e to the power x plus e to the power minus of x dx, right? From here, if you evaluate this, so first of all, let us see how we are going to solve this, right? So if we can just simply multiply this part and let us see what we get, right? So we'll later put the limits. One upon, so if we solve it, if we solve this, we are going to get it as e to the power 2 to the power x plus e to the power 0 minus e to, sorry, there is a minus sign over here, minus e to the power 0 minus e to the power minus of 2x, right? So we evaluate this basically going to be the part of the product. All right, now if we just try to solve this part, what we can do, we can see over here this part and this part will cancel out, right? So we are ultimately left out with a part as, so the part of the integrand that you are going to see over here, so we will have this as 1 upon e to the power 2x plus, sorry, minus e to the power 2x dx, right? So if we further evaluate this is very simple. We can evaluate this as, within the given limit, the integral is 1 e to the power 2x divided by e to the power 4x minus 1 dx, right? So how we are getting this step is just simply we are writing e to the power minus of 2x as 1 upon e to the power 2x, and that's how we solved it, right? So simplifying this, now we will basically use the step of substitution, that is let us assume that e to the power 2x has some constant as t. So we'll proceed from here is that we assume this as t, and then if we differentiate both the side, I will get 2 into e to the power 2x dx as dt, right? So we can solve it further by substituting. So what we will do over here is that a simple step of integration by substitution. So we will simplify it as integral within the given limit. I am not putting the limit right now. So the substitution will be very simple. It is basically, so over here I am having e to the power 2x dx, right? So e to the power 2x dx is basically dt by 2, right? So 1 by 2 will come out as constant, and that is going to be dt divided by, now this is e to the power 4x, that is going to become equal to t square minus 1, right? As simple as that. I'll put the limit later on, or you can put the limit in t also and you solve the answer. So if we have the result as natural log root 2, so in place of x, if you put natural log root 2 over here, so you are going to get t as, so you are going to get t as 2, right? And for the upper limit log root 3, so you're going to get 3 t as 3, as simple as that. So we just put the limit over here 2 to 3, and we evaluate this part. So I can write it half times of integral 2 to 3. Now this part I can split that as 1 upon t minus 1 into t plus 1 dt, right? So further on we can simplify it as half times of within the limit 2 to 3, and now there is a very minor step over here, that is basically we can also do it by using partial fractions, but we can avoid the partial fraction by just by writing, like we can do the simplification by ourselves only, that is 1 by 1 minus t minus of 1 by 1 plus t, okay, as simple as that. And from here if we separate the integral and we solve it, so we are going to get the result as, so I'm carrying forward the calculations over here. So from here I will get the integral as 1 by 2 is a constant part that's out of the integral, so 1 upon, please don't confuse by this 2 over here, it is basically the lower limit of that integral. Okay, I'm writing it over here. Okay, fine. So this is the next step, and then from here 1 by t minus 1, if we take the integral of it, it is going to be equal to natural log t minus 1 minus of natural log t plus 1, right, within the mod. But we are not putting a mod because t is basically in the positive region only. So within the interval 2 to 3. So which we can simplify and write it as half times of natural logarithm of t minus 1 divided by t plus 1 within the given limit 2 to 3, and that is going to be half times of natural log of, so if you put 3 over here, we're going to get it 2 by 4, and over here, and minus 1 by 3. So from here the part that we get the answer as, so I'm writing the answer over here in the top part. So from here I'll get the result as, so by putting the limit, so we get the answer as half times of, this is natural log of half minus natural log of 1/3. So that is, if you perform this, it is going to be natural log 3 by 2. So and then, so this is going to be the final answer of the integral. That is going to be the final answer of your integral. Okay. So there are certain step jumps that I have did over here, is that it is very simple. It's basically the property of the logarithmic. So I'm writing the properties over here in this space. I hope the step is clear, right? So the logarithm step that I'm using basically is that log a minus log b with a common base is going to be equal to log of a upon b. Got it? If you have any query, you can post that on the message. Okay. All right. I hope this is clear. Fine. So with this, let's move to the next problem. Another very similar problem from the cbse previous year problems. So this problem is basically to find out a constant part, right? So the question says that we are provided with the integral within 0 to 2 e to the power 2 times of e to the power 2x dx is equal to integral 0 to a e to the power x dx. So we need to find out the value of a, right? It's a very simple problem and a one marker questions. So how are you going to solve this problem when you're going to come it up? So first of all, you will write the given equation as, you will write the given equation, then try to solve the integral on both the sides. So if we solve the integral on the left hand side, we'll get it as, so integral of e to the power x dx is equal to e to the power x plus c. Okay, so using this formula, so we are getting it. So 2 is a constant, will come out of the integral. So it is 2 times of e to the power 2x by 2 within the limit 0 to 2. So and that part is equal to e to the power x within the limit 0 to a. So if we carry forward the simplification over here, we will be getting it as 2 and 2 will cancel out. So we are left out with the part as e to the power 4 minus of 1, and that's equals to e to the power a minus of 1. So from here, but just by directly comparing both the sides, we are going to see it that a is equal to 4. So that's the solution for this problem. So very simple problem. So again, option number C is going to be the answer. Very simple, very straightforward, one marker problem. Alright. So with this, let's move to the next problem. Alright, so again we have an interesting problem which we'll be talking about, with which we will be talking about a substitution method. Now, if you don't recall from substitution, let me tell you, let us recall. So very simple, it is like, so whenever you have like f of, let us say we have f of ax dx in the inside the function, and I want to integrate within the given limit. I'm not showing the limit over here, but what we can do is that I can assume this a into x as some constant, let us say, and if we differentiate both the sides, I'm going to get it as a times of dx is equal to d of t. So I'm just changing the variable from x to t by assuming this part. So from here I will come back and I will get the result as f of t dt. Now what I'm doing, in place of dx, I'm replacing this as dt upon 2. So from here I will replace this dx as dt upon 2. So that's what we carry out the integration by substitution. I hope this was a good recall for all of you. So with this, let's proceed for this real problem. So this was a problem that was asked in the previous paper of cbse. So we are going to solve it as, so let us first of all write the integral. So it is from 0 to a cube, and it is like x square divided by x to the power 6 plus a to the power 6 dx. So again the same step, whenever this will come up for your cbse examination, you will first of all assume this integral as some integral as I. What you will do from here is that I is equal to integral 0 to a cube, so x squared dx divided by x to the power 6 plus a to the power 6. Now for the sake of simplicity, I will assume, let us assume that this x cube, let us say this is basically equal to t. Now why I am assuming this, you will get to see in a minute, that if I differentiate both the side with respect to x and t, so I will get it as 3x squared dx is equal to d of t, right? So what is the advantage over here is that I already have in the numerator x squared dx. So from here I just substitute it back, so I will get this as x squared dx as dt by 3. So that's the advantage of, I will have it over here. So therefore now if I see what is the value of the t for this upper part and the lower part of the limit, I will get it as, so t is basically going from 0 to a. So instead of a cube, I'm going to 0 to a. So over here, this is going to be basically equal to dt upon 3, and the denominator is going to be equal to t square plus a to the power 6. Now a to the power 6 is a constant, you can treat it as a constant, and then it's a very simple integral. So 1 upon 3 is basically a constant that will come out of the integral. So 0 to a, and it is basically dt upon t square plus some constant, let us call that as k. So from here, if you know that, or let us say it is k square, for the sake of simplicity, it will be easier for you to understand. or even if you don't want to do this particular step, you can definitely keep it in terms of a to the power 6. So but I will write it as a cube whole square. Fine. So from here, this is basically the form that integral dx upon x square plus a square, it is basically nothing but tan inverse of x upon a plus c. So we apply this formula. So whenever this part comes up for your CBSE board, you definitely have to mention this. From this part, it is coming this. Okay, so this will give you a better impression for the examiner to evaluate your marks, right? So you have no scope given to the examiner to deduct your marks, right? So we solve it over here. So from here, I'm making best possible use of the space, so I hope you can understand. So from here, the integral result will be 1 by 3 times of tan inverse of t upon a cube, and within the limit 0 to a, and that part is equal to 1 by 3 tan inverse of a upon a cube minus tan inverse of 0, right? So if we evaluate this, we are going to get it as 1/3 upon tan inverse of 1 upon a square, and that's going to be the required answer to the problem. I hope this is clear. With this, let's move to the next problem. And the next problem, again, a very similar problem of integral. Now, instead of the definite integral, I took a problem of integral just to show you like how we are going to apply the substitution methods in different problems. So again, a similar problem. So we will again write it as, let the integral I be equals to integral x square sine inverse of x to the power 3 by 2 dx, right? So now you must be wondering like how to proceed with this problem, right? So another very important and interesting step over here is that let's us assume x cube has some constant t, not a constant, so another variable t, right? So why we're doing it? Again, because we have x square and a dx part over here, so I'm trying to simplify it as, so what I can write as, so this given integral can also be written as integral, so I can write it as 3x square dx is equal to dt, right? So from this part I will get x square dx as dt by 3, right? So 1 upon 3 I can take it out at common, so dt will basically be equal to, so dt times sine inverse of, so I should not write like this way, okay, I should write the dt at the end. So sine inverse of, so now I assume this x cube as t, right? So this is going to be square root of t, right? And I have dt over here. Now if you want to change the square root also, you can do it, that's totally up to you, okay? But I won't be simplifying it further. It's basically your homework statement, okay? You can definitely solve it as a part of your homework and can comment me in the comment section, okay? I will love to have your answers. So from here you have to proceed this problem by parts. So I hope you know how to proceed by parts. It's very simple. For example, let us say you have two functions and you have to evaluate the integral for it. So let us say this is the first function and the second function. So by part says that it is basically first function into integration of the second function minus differentiation of the first function into integral of the second function and then the integral of that with respect, right? So this is how we are going to perform the by parts. So you please solve this as a part of your homework, okay, and you will get to know. Simple and clear, right? Any confusion you can mention me in the comment section as well as in the chats, okay? Fine, I'm waiting for your replies. Okay, so I hope you will be getting this part from here and you can get me and come up with the answer in the comment section. I will be love to hear from you, okay? With this, let's move to the next problem. Another very simple straightforward problem which directly just applying the formula and getting the value. So again, a one marker problem. So in this class, what we are doing is basically we are mostly discussing the one marker problems especially. So if you see this problem, again a very simple problem, it is said that the integral within the limit 0 to a 1 upon 4 plus x squared dx is basically given as pi by 6, right? So you have to find the value of this unknown upper limit. So what we'll do, we know that this particular integral, so whenever this question comes up, so for please don't forget to mention the formula. Okay, so integral of dx by x square plus a square is equals to tan inverse of x upon a plus constant. So we'll do this in evaluation of the integral. So it's a one mark problem, so you can evaluate it quickly also. So it will basically will be equal to tan inverse of x upon 2, because 4 is basically 2 square. So within the limit 0 to a, and the integral is given as pi upon 6. So you further evaluate this, you will get it as tan inverse of a by 2 is basically equal to pi upon 6. Now this problem is basically nothing is mentioned, so we definitely have to talk about the principal argument. So from here we will evaluate this part as, so a upon 2 is going to be equal to tan of pi upon 6, and that's going to be 1 upon root 3. So from here you will get the value of a as 2 upon root 3. You can check. All right, so I hope this is clear. uh, I think there is a issue in the problems. Okay, this is like, this is part is like 2 by root 3. Okay, all right. If I have done any mistake, you can point me out. I hope this is clear. All right, so with this, let's move to the next problem. And the next problem is a useful and critical problem. So many students definitely fear from this type of problems is that just because it has multiple intervals. So again, now in order to solve these problems, I will take help of that particular theorem, that is, we can split the integral within multiple parts. So let us say I have an integral from a to b f of x dx. I can split that into multiple parts from a to c f of x dx plus from c to b f of x dx. Okay, so it is like piecewise continuous. So we just split the part of the integral into multiple region and we try to evaluate this. So from here, if we try to evaluate this from 1 to 3, x minus 1 mod of it plus x minus 2 mod of it plus x minus 3 mod of it, and we try to evaluate this integral, right? So you can see that x is always greater than 1. So from this limit, what we understand is that x is lying between 1 to 3, right? So in between, so since x is greater than 1, it is always going to open up in positive sign. And similarly, but the problem is like, we don't know that in what particular fashion this x minus 2 and x minus 3 is going to be evaluated as, right? So what I will do, I will try to write it, I will split this in between 1 to 2. So when I'm splitting in between 1 to 2, this integral will basically will be equal to x minus 1 plus minus of x minus 2, because when we are opening for the mod part, we'll basically evaluate this as negative of it, because x is basically between 1 to 2, that is less than 1, less than 2, right? So for less than 2 part, this part will be opening up in negative, and this part will also open up in negative, so that is going to be minus of x minus 3. So that is going to be dx over here, plus integral 2 to 3, and in the integral 2 to 3, this will be like this, the x minus 2 part will be evaluated as positive, and this part is going to be evaluated in negative. So from here we can simply solve it this part. So if we just evaluate this part is going to be simple as, so you can see this minus of x and plus of x will cancel out, and we're left out with the result as 1 minus x is will be there, minus of x minus 1 plus of 2, that is going to be plus of 1, and plus of 3, that's going to be plus of 4. So minus x plus 4 within the limit 1 to 2 dx plus, and this particular evaluation will be like, see, this minus x and minus x got cancelled, and I will have x minus 2 minus 3 and plus 3. So that is going to be 0, right? So that is x within the limit 2 to 3 dx, right? So now we just simply evaluate this. So I am evaluating this over here. Now this is a 2 marker problem, what you can expect, or a 3 marker problem also. So whenever this type of question comes up, please don't forget to mention that how we are basically opening this interval, right? So from here you will see that the result is going to be like minus of x square by 2 plus 4x within the limit 1 to 2 plus x square by 2 within the limit 2 to 3. So you can just simply evaluate this and you can get to the answer. I hope it is pretty straightforward. Anyone got the answer? Alright, so I leave it this up to you. Okay, you can evaluate the answer and come up with the answer. Okay, and definitely mention that in the comment section as well. Alright, so is it clear? I hope this part is clear. So whenever you will be solving this problem for your board examinations, so what you will be writing is that please mention that the definition of the function mod of x, right? So mod of x is equal to plus of x when x is greater than or equal to 0, and it is equal to minus of x when x is less than 0. So that's how you are going to write it up. Fine. So I hope this part is simple and clear enough. You please come up with the answer and let me know in the comment section. Okay, I'll be very happy to reply to your query. With this, let's move to the last problem. Okay, and I have some homework problems for you, which is basically simple to that the same problem that we actually solved it, right? Now you can see this problem is very simple and straightforward problem for your cbse board exams previous year paper. Okay, and you can also find the similar problem in the ncert as well. Okay, so I leave this problem also as a homework problem for you. All right, so let's evaluate this problem. So again, now with the help of this integral, we have to solve for the area under the curve, right? So what we see, let us first of all understand what is the region. So again, in order to solve the questions of area under the curve, I will again mention my region. So first of all, if I look at this, my region is basically bounded by this ellipse x square by 16 plus y square by 4 is equal to 1, right? So and this is particular ellipse is also bounded by two lines, that is in between x is equal to 2 and x is equal to plus 2, right? So again, the simple steps is basically to try to plot the ellipse. Now in order to plot the ellipse, it is better to have the idea of eccentricity. So if you don't know eccentricity, I am recalling the eccentricity. It is basically equal to square root of 1 minus b square by a square for the ellipse defined as x square by a square plus y square by b square is equal to 1. So that is the equation of a general equation of an ellipse with a center at origin. Okay, so for this ellipse, the eccentricity is given as 1 minus b square by a square, square root of that. All right, so if we just evaluate this eccentricity, I am going to have it as 1 upon 1 minus 1 by 4, and that part is going to be square root of 3 by root 3 by 2, right? So we are having the eccentricity as root 3 by 2. Fine. All right, so then, and we know that the points where the ellipse basically cuts the x and y axis is given as x axis is plus minus a. So what is a is basically this part. So a over here is basically plus minus 4. So I will write as plus 4 and this part will be minus of 4. And similarly on the y axis is going to be plus of 2 and it is minus of 2, right? So we will have an ellipse like this, right? So please ignore my diagram. I'm trying to drawing it. Okay, so now we have to find out the ellipse which bounded by the area is x is equal to minus of 2 to x equal to plus of 2. So we will put the interval and that is my given region, right? Now interesting way to solve this integral is that when we are finding out the area, it is not necessary to find out the entire area together. What we can do, since this ellipse is symmetric about the x as well as the y axis, how we are going to check for symmetricity, that is an interesting thing that I'm going to discuss. Let me discuss over here. Okay, so symmetricity. So what you can do, in place of x you can put minus of x, and in place of y you can put minus of y. So if you evaluate with x equals minus of x and y equals minus of y, you're going to get the same equation, right? So that is basically even in x as well as even in y, right? Right, so if you just separate this ellipse equation into x as well as y, you will find out that it is basically even in both x and y, right? So it is equal to, just calculate this particular area. So it is just equivalent to calculate this particular area. I hope the color is visible to you. If not, if I just use a different color. Yeah, so this part of the integral I will calculate. Okay, this part of the integral I will calculate as the area and I multiply by 4 to get the required area, right? So that's going to be the idea. So let us do it over here. Let us carry forward the solution. So if we carry forward with the solution, so our given integral, that particular area I'm going to have it as integral from 0 to plus of 2 and 4 times of that particular from 0 to plus of 2, and I have to separate this y in terms of x, or you can do it other way also, right? It's totally up to you. So I will just do the easy way around. So I will do it the easy way around, and the y part is equals to, so I can write y square upon 4 is equal to 1 minus x square upon 16, and from here I can write y square is equals to 4 times of 1 minus x square upon 16, and if we just take the square root of both the side, so y equals to square root of this part, right? So that I'm going to have it as 2 square root of 16 minus x square by 4, right? So this is going to be half times of 16 minus x square, right? As simple as that. So I'm just writing it over here. This part is going to be 1 upon 2 square root of 16 minus x square dx, right? But the thing is, like, I don't need the total area, I need this part of the area, right? This part, right? So that's why we bounded it between 0 to 2. Clear? Now, how are we going to evaluate this particular integral is totally up to you. So we will be just integrating it from 0 to 2, and the integral is basically given as root under 16 minus x square dx. Now the interesting way to solve this problem can be basically by help of substitutions. What we can do is that I'm continuing over here. I hope it won't create a problem. So if I just continue it over here, so let me continue it over here. So I was going to evaluate the area, and the area was coming as 2 times of integral 0 to 2 square root of 16 minus x square dx, right? So how are we going to evaluate this integral? The simple way is basically to substitute x equals to some 4 cos theta or sine theta. Okay, now why do we are doing that? It is basically a standard substitution, that is, you put 4 sine theta or cos theta, whatever you feel like. Alright, so if I just put it this, so then my dx is going to be equal to, dx is 4 times of cos theta d theta, right? So I just substituted back it over here. Now you will understand that why I did this. So it is integral 0 to 2 square root of 16 minus, if I take 16 common, because x square is going to be equal to 16 sine square theta. So 16, if it's taken common, 1 minus sine square theta, and that will basically come out as, right, and then this part dx, and this part of dx, will be evaluated as 4 times of cos theta d theta, right? Now from here we can solve it further, so I'm solving it over here. I hope the substitution is clear, right? So I will write it over here, the substitution. Okay, so I'm substituting x equal to 4 times of sine theta. Now, this is one of the standard substitution in trigonometry, right? So from here I'll get the integral as 2 times of square root within the, so I will put the limit later, but let us first of all write it over here. So square root of 16 is going to be 4, and 4 and 4 is going to be 16 again. So again this part is going to be, now 1 minus sine square theta is going to be equal to cos square theta. So this part is cos square theta, and square root of cos square theta is going to be equal to cos of theta. So this part is going to be 4 cos theta. So ultimately it is going to be equal to 16 times cos square theta 0 d theta, right? And if we look at the limits, so limit is basically from 0 to, now if x is equal to theta is equal to pi by 6, right? So from here we just evaluate this part. So this is going to be 32 times of 0 to pi by 6 cos square theta d theta. Now I can again use a simple algebra trigonometric formula, that let us continue it over here only. So I just continue it over here. So I can write cos square theta as 1 plus cos 2 theta divided by 2, right? So that is basically equal to cos square theta is just by the half angle transformations. I hope you remember, right? So from here I can substitute this integral back as, so let me erase it. I hope you have done this part. So from here, so I'm just solving it from here. So it is going to be 32 upon 2, that is going to be 16, and again we'll have 16 times of, so within the limit 1 plus cos 2 theta, right? So I've taken 2 already as common, so then it's going to be the relation, right? Now this part from 0 to pi by 6, so I can evaluate this as 16 times of, now this integral is going to be equal to pi minus pi plus sine 2 theta by 2 within the limit 0 to pi by 6, right? And this part, if we evaluate it, we will get to the required answer as 16 times of pi by 6, and if we put pi by 6 over here, it's going to be sine of 60, that is going to be root 3 by 2, that is plus root 3 by 4, right? And if we put 0, it's going to be 0, so that is going to be the required result for the solution of the answer, that is we have to find out the equation of this particular ellipse, right? Is it clear? So I hope this part is clear to all of you. So I have left out two problems as a homework problem, that is this problem as a homework problem, as well as I have left out a part of this portion as a homework problem to all of you. I hope you will be able to solve this integral parts by yourself and come up with the answer in the comment section. So I hope you enjoyed watching this content. So with this, I'm concluding this part. So I hope this entire solutions of discussing the previous problem was clear to all of you. All right.